we're going to be working in section 7.1, and we're going to be talking about solving trigonometric equations with identities. So let's start by remembering what identities we have learned so far. This page gives us the whole list of identities that you should have memorized by this point in the class. So we've got the Pythagorean identities in all three of its forms. Now, the one that I really care that you memorize, you absolutely need to memorize this one. You can get to these other two from this one. So if memorization is something you struggle with, focus on the top one. We need to know our negative angle formulas, or our negative angle identities, so you need to know this one and this one. And you can get to the other two from just that one. But that means you have to memorize all of these. So I really am trying to give you hints. If you struggle with memorization, the things that I have marked here in red are the things that you need to memorize, but you have to be able to get to everything else on this page if you choose to only memorize that small amount. So make sure you can derive the ones that I'm going to mark in blue. If you don't memorize them, you need to be able to derive them. So it's one way or another, you need to know everything on this slide. Okay, red means memorize. Blue means memorize or derive. Whichever is easier for you. Okay, so let's start looking at examples of how we apply these things. And we're going to do a couple where we actually don't use identities. So let's start by solving this equation. Now this equation looks like it could be quadratic. It's almost quadratic, except we've got cosine instead of sine, instead of x. What we usually say is this is quadratic in cosine. Now here's how we're going to solve this. We're going to use a placeholder. We're going to let u equal cosine of t. So everywhere we see cosine, we're going to replace it with u. This means our equation now becomes 2u squared plus u equals 0. And we can solve this, right? This is just a quadratic formula. We're good at these. Let's factor out the u. So we get 2u plus 1 equals 0. So that means that u equals 0, or u equals negative 1/2. Now let's undo that substitution that we did a minute ago. And what we're going to find is that that means that the cosine of t equals 0, or the cosine of t equals negative 1/2. Now consult your unit circle or your memory, hopefully your memory, but if not, then your unit circle. And you'll find that cosine of t, or the cosine of negative 1/2, results in 4 solutions. 0, 3 pi over 2, 2 pi over 3, and 4 pi over 3. Let's consult Desmos, check a graph, just to make sure we didn't miss anything. There it is. Okay, so what I've done is I've graphed y equals 2 cosine squared x plus cosine x And we are looking for where this equals 0. And on all of our problems today, we're going to limit ourselves to 1 revolution around the unit circle. So that means between 0 and 2 pi. So my graph is limited to 0 to 2 pi. And you can see we've got a solution here at, because we're looking for where this equals 0. So we can put on the line y equals 0 and look for intersections. And we'll find one here at pi over 2. What did I do when I solved this? What did I do? Who sees it? I read the wrong coordinates. So cosine of 0 does not equal to the angle is 0. Cosine equals 0 means that, oh yeah, I was right. No, I wasn't. Pi over 2 and 3 pi over 2. These two come from cosine equals 0. And cosine is negative 1/2 at 4 pi over 3 and 2 pi over 3. All right, better. So now if we look at our graph, we've got pi over 2, we've got 2 pi over 3, we've got 4 pi over 3, and 3 pi over 2. Not that hard. Now, what you do need to know is you do need to know where does cosine of an angle equal 0, for what angles, and for what angles does cosine equal negative 1/2. These are unit circle values. You should have these memorized. All right. Let's try another one. This one's very similar. In fact, there are no surprises here. So I'm going to ask you to go ahead and pause this presentation and try it for yourself. So pause the presentation now. When you're ready, come back and restart the presentation and I will put up the answers. All right, the solutions to this problem are t equals pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. If you did not get those, or if you're not sure how to get those, please shoot me an email or come to the next scheduled web conference. Okay, let's try another one. We're going to do this one together. We're going to solve 2 cosine squared t plus 5 cosine t minus 3 equals 0. And that's because there's a complication I want to talk to you about. But let's start by letting u equal the cosine of t. That means that our equation now is 2u squared plus 5u minus 3 equals 0. This is again a quadratic equation. We've got a couple of ways that we can solve this. I factored it. This will factor as 2u minus 1 times u plus 3. You could also use a quadratic formula. But either way, you're going to get that u equals 1/2 or u equals negative 3, which means that cosine of my angle is going to be 1/2, or I'm looking for angles whose cosine are negative 3. Now, what's the range on cosine? Yeah, it's negative 1 to 1, right? Cosine of x is never going to equal negative 3, so we can toss this out. It's an erroneous solution. There are no angles whose cosine is negative 3. So that means we can just work with cosine of t equals 1/2. And t is going to be pi over 3 or 5 pi over 3. Now, if you're thinking, but wait a minute, we just worked with all of these things where we made cosine bounce between different things. Yes, we did. We did that because we had multipliers inside. So the only way to get cosine to be -3 is if we have something that affects the amplitude. We would have to have a stretch. This equation does not have any provisions for a stretch. So we're going to toss out any solutions that are outside the range of cosine. Okay. Now, what are we going to do here? We've got mixed cosine and sine. This isn't quadratic in either one of them, is it? Here come our identities. The first thing we have to do when we are solving these things is get everything in terms of one function. So we have to have sines or all sines or all tangents. So you get the idea. This is why we have those identities. So let's remember what our identities are. We've got one that relates cosine squared to sine squared. That'll work. So we know that the cosine squared of an angle plus the sine squared of that angle equals 1, which means that my cosine squared is going to be 1 minus sine squared. Okay, so instead of writing cosine squared, we're going to write 1 minus sine squared. So this is going to be 2 times 1 minus sine squared t plus sine t minus 1 equals 0. Distribute my 2 through, and I've got 2 minus 2 sine squared t plus sine t minus 1 equals 0. Combine like terms, we end up with -2 sine squared t plus sine t plus 1 equals 0. I don't like this negative sign in front. I'm going to multiply through by a -1 on both sides. So I get 2 sine squared t minus sine t minus 1 equals 0. We could factor this. We could use the quadratic formula. Either way, you go through the same steps that we went through for the previous 2 examples, and we end up with, you should be able to end up with sine t equals 1 or sine t equals -1/2. If you have troubles getting to this point, please shoot me an email or come to the next web conference. Check Canvas for when that will be. And either way, we get to this point, we can solve this, and we get t equals, 0 or 2 pi. Yes. No, that's not right. Where does sine equal 1? Sine equals 1 at pi. At pi. And where does sine equal -1/2? Sine equals -1/2 at, those are right, 7 pi over 6 and 11 pi over 6. Let's go consult Desmos real quick. Desmos doesn't care if everything's the same. So let's see, we've got 2 cosine squared x plus sine x minus 1 equals 0. And yes, we've got pi over 2, pi over 2, 7 pi over 6, and 11 pi over 6. All right. So what are we going to do here? Okay, what's cotangent? Well, cotangent, so we got to make our functions match. We've got cotangent of A equals 2 cosine A. All right, well, let's see. Cotangent, we know, is 1 over tangent. That doesn't really help me. But I remember that tangent is sine over cosine, so this is going to be cosine A over sine A. Oh, this might work. Let's try this. So instead of cotangent, we're going to write cosine over sine. So that means I've got cosine of A over sine of A equals 2 cosine of A. Ooh, let's pull everything to one side. So I've got 2 cosine A minus cosine A over sine A. Yep. Factor out the cosines. And I've got cosine of A times 2 minus 1 over sine A equals 0. That means cosine equals 0, or 1 over sine equals 2, so sine equals 1/2. And now we need to make a note here that my sine of A cannot equal 0. Okay, so cosine A. Cosine equals 0 when A equals pi over 2 and 3 pi over 2. Sine equals 1/2 at pi over 3 and no, sine equals 1/2 at pi over 6. Sorry. And at 5 pi over 6. And A cannot be A cannot be 0 or pi or 2 pi. All right, let's checkmate. This one's a little funky. Okay, so let's do it this way. We've got cotangent on one side of my equation, and I've got 2 cosine on the other side of my equation. And according to this, I see 4 intersection points. You see one right here. At pi over 6, and at pi over 2, and at 5 pi over 6, and at 3 pi over 2. There are no other intersection points, so yeah, we have found the correct solutions. Okay. You're going to do this one just exactly the same way as we did the first one. So I'm going to leave this one for you to try. Again, if you struggle with this, shoot me an email or come to the next scheduled web conference. And what I would like to do is I'm going to have you pause the presentation here, and I will put up the solutions. So when you are ready, restart the presentation and see if you got it right. The solutions to this one are x equals 0, pi, and pi over 2. Since I'm having difficulties with my memory today, let's check that on decimals. We'll put the left-hand side on one line. 1 plus sine of negative x. And the right-hand side on the other line. And let's see what we get. Well, we've got an intersection here at 0, and at pi over 2, and at pi, whoops, and there's one more right out here at 2 pi, so we should put that in as well. Okay. Have a great day, do good math, and I will see you all again soon.